So this is our senior project. We ended up spending the last 4 to 5 months writing over 2 inches of paper. Ended up going through proposals, functional specifications, block diagram, time and task schedule of this semester, bill of materials, design schematics and drawings, and a final design report. Everything else is all of the data sheets for all the parts. The main part of this project is basically taking a smoker and turning it into a functional product that people are able to take a piece of meat, chicken, beef, whatever, even fish, put it in the smoker, put the temperature probes in, and be able to automatically cook any piece of meat to the temperature that they want at the finish time they want. Our project is the Smart Smoker. Originally, it was a 15.5 gallon keg that would have an electrical box, a spritzer liquid container for like apple juice or apple cider vinegar, with a tube that would then go to a misting nozzle that would have the ability to make the keg very moisturized, just because as meat cooks, it loses its moisture and essentially sweats out a lot of the juices, and then the spritzer would be able to reintroduce all that moisture. We'd have legs that would be the pipes that we would have to cut and weld to the thing, a wood chip tray. We'd have to cut into the keg for the door, and then inside is the grill tray, wood chip tray. This just shows where it is. So this is on the right side of the keg, where the electrical box, the tube, also a thermal camera that would be pointed inside the keg to make sure that the meat is cooking evenly, as well as figure out when the spritzer should be turned on or off. What would it cost? We ended up coming up with a parts list of around 564. Over the winter break, we ended up buying a few different parts and actually got it down to right around $365. Design requirements ended up being the manufacturer cost. We wanted to keep it at least around 700, at most 1,000. Temperature sensors, we want to keep it around 2 degrees Fahrenheit, 8 degrees at most. That's just because when the piece of meat is cooking, it doesn't have that much of variability. I know a lot of people that do smoke meat. 8 degrees is a lot of room, but those are the connoisseurs. Functionality website, we will be making a website for this smoker. We'll get to the block diagram later. Obviously, we want to have as little clicks as possible. Time to process temperature data, we're keeping it to 1 to 5 minutes because we're going to use a microcontroller that will get and post objects from the database. Power requirement, 1400 watts in total and 2000 watts at most, just because most of the people that would be using this product are going to be plugging it into a 15 amp breaker. So we want to keep it as low as possible, but also we're going to be pulling a lot of heat anyway just because of the heating element. Heat source cutoff temperature will go up in temperature just because we ended up buying a Weber grill rather than a keg, just because it was $90 versus almost 200 to 250 just in parts of assembling a thing of the keg. And also we would have to cut and do metal work. This is the block diagram, pretty much how the physical and software components are going to be set up. We have the ESP32 in the center. It is a microcontroller that will talk to all of our physical aspects, and then on top of that, this is the website down here. We have a database that will be in PostgreSQL, and then we have our .NET, which will be our server side, Angular as our client side, and then all of this will interface with the ESP32. ESP32 will use GET and POST HTTP requests to interact with this website, and the ESP32 will then be hooked up to great drivers, MOSFETs, different power supplies for the rectifiers, and the spritzer thermal camera, the two meat probe temperature sensors, and the ambient smoker temperature sensor. So all of this will be data that will then, the ESP32 will then post to the services that will then put it into the database. Then the website will then, and based on the API command that the ESP32 will post, the website will then realize that a new set of data is there, and then the website will then figure out what the next temperature should be and then post it to the database. Then the ESP32 will then get that desired condition. So if anybody has figured out Kubernetes or anything like that, it's the idea of the desired state and current state. Whatever the current state is versus the desired state, the control or the node, which will be the ESP32, will figure out what the difference is and try to get to the desired state. This is the breakdown of all of the different things that we'll have to do for the Smart Smoker project. We have all of our research components, design components, hardware. Pretty much all of this was last semester. We still have to do a little bit of research to figure out how things work and everything like that. But the main thing will be assembling hardware casings, electrical circuits, and also a lot of code. This is a very intensive code project that will have to require the microcontroller, client side, server side, and the database to all work together, and then as well as testing all of this. Another thing we had to do was a critical path. The critical path, you can't see this because we printed in black and white, but all of the things that you saw before are the different tasks. Below each task is how many hours we pretty much expect to spend on that task. All of them are critical just because it's necessary to complete every component up until that point. This is the circuit that we ended up coming up with. This circuit will probably change based on the things I ended up doing today. We have the ESP32 in the center. We have our two audio jacks for the temperature probes because they are 3.5 millimeter jacks. And then we have the ambient temperature sensor that uses a PT100 thermopile, or not thermopile. This is a thermopile array up here, which is essentially a camera, but it's a 32 by 24 infrared matrix of different values that we'll be able to read based on the meat temperature, and then that will be used for the spritzer that's up here. This motor will run and it will dispense all of the liquid at different intervals. It is also driven by a motor driver. We have our two rectifiers. This is the 5-volt one. This is the 12-volt one for the motor driver. Then the ESP32 will then connect to the gate driver. The gate driver we might not need because this MOSFET here is the threshold voltage is 3 volts. For the heating element to turn on and off, we have our switching from our wall outlet. So this ESP32 probably doesn't need this gate driver just because the threshold voltage for this MOSFET is pretty low. This channel will end up documenting the process of building the actual smoker itself and also figuring out if we spent the last 4 to 5 months telling the professors that we can do something that we can't actually do. So let's figure out if we can do it.